right, so this example problem is just going to get us used to and comfortable with the idea of relativistic energy. And it's asking us to calculate the rest energy and the kinetic energy of a 100-gram ball at 100 meters per second and of an electron at 0.999 C. So moving really, really fast. Well, 100 meters per second is on the order of a very slow relative to the speed of light. So we're going to look at both the ball, and if we think about its rest energy, the rest energy is mc squared. We're told the mass of the ball is 100 grams, so 0.1 times 3 e to the 8th quantity squared. The amount of rest energy that that ball has is 9 times 10 to the 15 joules, so a lot of energy in its rest energy state. The kinetic energy of the ball, because V is so much smaller than C, we can use the classic kinetic energy relationship, and we find that that ball has 500 joules. So just familiarizing ourselves with the verbiage, as well as kind of recognizing that when the velocity is much, much less than c, we can use that binomial expansion, which leads to the 1/2 mv squared, and we just calculate the kinetic energy. So let's compare that to the electron. Let's look at how that looks. In the electron's case, the rest energy is the same relationship. It's mc squared, and we know the mass of an electron, we know the speed of light. This leads us to 8.2 times 10 to the minus 14th joules. Okay, so a little bit of energy there. Kinetic energy, we have to use the relativistic kinetic energy, which is gamma minus 1 times mc squared. Now, remember what this relationship was. It's the square root of 1 minus v squared over c squared. So in our case, 1 minus 0.999 c over c, and that quantity squared. And we get a value of 22.4. So we're going to plug that in. And we find the kinetic energy of our electron is 175 times 10 to the minus 14 joules. So what do we notice about this? We notice that the kinetic energy becomes pretty important in our electron's case as compared to the rest energy. It's bigger as compared to that rest energy. So kind of a fun little observation, as opposed to the ball, whose rest energy is huge relative to its kinetic energy. Okay, so just familiarizing ourselves with that idea of relativistic energy, the idea of rest energy, and getting comfortable with those relationships. Good job.